Hello everyone. In this video, we are going to see about sum of elements of two array in assembly language using EMU8086 and Lab kit. So, in order to do that, we have to understand the logics for giving an array and how to add two elements of an array. So, first, in the previous programs, what we have seen till now, we have understood how to calculate the sum and average of numbers. And after that one, we have seen how to add all the elements of that array, and the video has been in description. So in this program, so we are going to see how we can able to use that for adding two array elements. So assume that you are having two array elements in a sequence of memory location like this. How to add those two elements and keep it in same array. That's what we are going to see. So this is our array 1 and this is your array 2. So it should be having same number of elements, then only we can able to have it sum. So in this one, if you want to make it, so this should be in a specific memory location. So assume that I'm going to give a memory location of 2000 and after that 2001. So each one is going to be 8-bit. So 2002 and 2003. So assume that the elements which are going to be here is going to be 01, 02, 03 and 04. Assume that one more element is there, 05. So I can able to take one more element here also. So for easy understanding, I will keep the same elements here also. So after that it is going to be 04, after that it is going to be 05. So this memory location is going to be 2004. So it can be starting from the memory location of 2010, 2011, 2012, 2013 and 2014. So these are random memory locations which I want to choose. You can able to choose whatever memory location you want. So now I have to add those elements. So if that is going to be happening, so I don't have any instruction to add two elements like this. So both the things should not be in memory location 2010, right? So I can able to add it directly. So this can be your destination and this is your source. So I don't have any instruction like this. So I'm having only instruction which can able to do that operation with an accumulator. So I can able to move something like this. So I can able to move from one location to another location. So same addition operation also is not possible here. So but if I want to add it like this, I can able to add it with some memory location. Right. So I have an expression or instruction like this, and this is also possible for your this kinds of instructions. So in order to do that in 8086, first I have to move any of the component inside your register. And after moving inside my register, I can able to add the memory location to that register and I can able to save it in the new memory location. So that is possible. So in that case, I can able to move. So my instructions, how I have to take. So move. I can able to take AL comma 2000. So for this instruction, so it is going to be 2000 here. So the element of 01 will be moved inside your AL. So it will be like your AL register is going to be 01. So now I can able to add the next element. So for that I have to give an instruction like this: add AL comma memory location of 2010. So now what will be happening? So this is your destination and this is your source. So AL is equal to AL plus address of location in that element. So here the element which is going to be present is also 01. So AL also will be having 01. So 01 plus 01, it is going to take it in terms of your 02 and the value will be stored inside your AL. So like this also I can able to do it and I can able to add those elements and keep it in AL. So after that I can able to move to any specific location which I want. Else if I want to save it in a memory location, I can able to do in this fashion also: add 2010 comma AL. So here, if I after getting that element, I have to move to specific memory location. So I have to move my some location of 2020 to the element of AL. So I'm increasing one more memory location here. But if I'm going to use something like this, so where I can able to move the elements of AL, add the element of AL, and I can able to add along with the element of 2010, and I can able to push it in the same memory location. So I can able to reduce the number of instructions if I'm going to use it like this. So if this happens, so I have to move to AL, and after that I have to push it to some memory location. Everything, whatever is convenient for me, I can able to do that. So first I have to move a memory location like 2000 to some address value, any address value of 8-bit. So after that one, I have to add that address value along with the next array's first element. And so this has to be added with each other, and your output should be 0, 2. And next one, your SI has to be incremented, which means, so I have to move to the next memory location. So I should not be giving like 2000. So what I can able to do, so previously I can able to declare SI as 2000. So DI as my 2010. So after completion of every addition operation, I can able to increment those SI and DI. So it can able to jump to the next memory locations. So overall, what are the first things which I have to do? So I have to do movement of elements of 2000 to and specific register. So register should get the values of memory, and after that I have to add it, and after that increment your SI and DI, and after that I have to repeat the loop. So how many times I have to repeat the loop? So I have to specify what is the size of my array. So initially I have to get the size of my array. So assume that, so usually we will take my count register as CX as your count register, right? So I have to declare this is my memory size. So count register has to be declared with 0, 5, so that I can able to understand 5 elements are there. So this operations has to be happening till this CX is becoming 0, 0. So what are the things I have to give? So I have to give the values of that array in specific memory location. After that, I have to specify how many times I have to repeat the loop, which means what is the size of my array. After getting both the things, so I have to move the contents of my memory to register, and after that I have to add it. I have to increment my DI and SI, and the loop has to be repeated again and again till the count is getting completed. So this is the logic which I am going to take for my programming. So I can able to do it with MASM 8086 programming. So with that we can able to see how this works. So this is a MASM program which I have written. So it will be having every instructions with a specific meaning. So first I'm taking my address location of 1000 and address location of DA as 1010, which means first array starts from the location of 1000 and the next array starts from the location of 1010, and my count register is going to be 5. So after that one, I have to move the value of first array to my AL register, and after that I have to add that AL register with the starting address of the next array, elements of starting address of the next array. So I have to add it like this: AL comma bracket DI, which means whatever the first element of your second array is going to be taken and it is going to be added with AL, and after that I can able to move that value of AL inside some specific memory location. Here I am giving it as SI because I am trying to replace the elements of my first array with the newly created array, which is going to be the addition of 2 arrays. So if you want, you can able to save it in different memory location also. But for my convenience, I am making it with DI. So if you want to make it with DI, you can able to make it. If you want to make it as SI, you can able to make it. And after that one, since in next iteration, next instruction, you are going to increment your SI, that is not going to disturb your SI. So SI and DI has to be incremented so that each and every array element will be getting incremented. So the next addition is going to happen. So it has to repeat the loop till this loop, which means your this loop instruction is going to decrement your CX every time. So previously the instruction is going to be 0005, your count register is 0005. After every iteration, it is going to decrement its CX. We don't have to decrement it by instruction. It will automatically decrement it and it will check for its CX value. So the loop will be repeated till your CX is getting 0, which means so your all the addition of every elements of the array has been completed. So after that one, I can able to emulate it and I can able to see it. So this is the instruction. So I can able to take it in sequence. So this is your instruction. This is your values of your register. And after that one, I have to give it in a memory, right? So I have to take my memory location and I have to keep it ready. AUX memory. So I can able to take it. So after that one, I have to check with my flags also. So flags I can able to keep it ready for my execution. So my starting address is going to be 1000. So your DS is at 0700. So I can able to give the address of 1000 here. So update it. So I can able to give with the elements one by one. 01, 02, 03, 04 and 05. So the elements are getting added to it. So after that one, it is going to be 1, 2, 3, 4, 5 elements, right? So your CX is going to be 05. So after that, in terms of your 1010 also, I can able to give the same elements, or if you want some other elements also, you can able to give it 03, 04, 05. So I can able to update it, and after that one, I can able to run the instruction one by one. So move SI comma 1000H, so which is going to move the value of 1000 to my SI. So the first element of your first array has been represented by SI. So after that one, I'm going to move to the next instruction. So your CX is going to be 05. So after that one, I have to specify my second array starting memory location. So your DA will be getting the value of 1010. So this is your 1010. So this is your array which is being saved in your next memory location. So after that one, move AL comma SI, which means the first array, first element has to be moved to your AL register. Yeah, 01, and it has been moved to your AL register. And after that one, if you want to add the next elements, how I can able to do that one? So add AL comma DI. So if I want to move to the next step, add AL comma DI. AL is already 01. So address of DI is 1010. So in that specific 1010, I'm already having 01. Both the thing will be added and it will be kept inside your AL register. So the both the things are getting added and it is getting it 02. So 02, I have to move to specific memory location. So here I'm making use of the first array memory location itself. So if you want to make it in terms of new memory location, you can able to give. So I can able to use it. So this 01 has to be replaced with 02, which is your addition of two elements, and it is going to be kept in the same array itself. So after that one, I can able to move it one by one. So increment your SI. So array SI is getting incremented. The SI is going to be 1011. So if I'm going to check for 1001, sorry, 1001. 1001 is going to be in this memory location. So 02 will be taken if I'm going to check in terms of address of 1001. So after that one, I have to increment my DA also, because parallelly I have to get these elements to add, right? So I have to increment your DA also. So this also incremented with 1011. So SI and DI can be added now. So memory location SI and DI can be taken with the elements, and after that I can able to add both elements now. So I have to repeat the loop. So the jump has to be happening one more time, right? So if the jump happens, so you can able to see the CX register becomes 0 0, and finally you can able to get the elements of 0A inside your final AL. So you can able to see 1 plus 1 is going to be 2, 2 plus 2 it is going to be 4, 3 plus 3 it is going to be 6, 4 plus 4 it is going to be 8, 5 plus 5 it is going to be 0A. So correspondingly we can able to add all the elements and keep it in the memory location which I want. So with this knowledge, we can able to directly enter into our programming with lab kit. So in our lab kit, only one thing we are going to change here, which means this loop we can't able to give it. Instead of using this loop, I have to give the specific memory location itself. So this is how we can able to write our program for lab kit. So only change which you are going to make here is giving the memory location. So we are having two arrays which is going to start from 2000 and 2010. So this is going to be from SI should be starting from 2000 and DA should be starting from 2010 as like the same. And after that one I am moving the elements of SI. So this is the memory address which I have to note it down to give it here. Instead of using loop 1 in your EMU8086, I can use my 100C memory location. So all the other things are going to be same. So SI, and after that DI, movement with DI, and after that one I can able to check with the elements of move the elements of AL to SI, and after that increment SI, increment DI. Only for this location I have to take the memory location of 1000 NC and I have to keep it here. And after that I have to press my halt. So this is a change which I am going to make from EMU8086 to LabKit. So we can able to move directly into lab programming. So first I have already typed the program, so I can able to directly give the command U. So if you want to type your program, you have to give the command A, and after that you have to give the starting address of the program and you have to start typing it. So here I can able to start typing my program. So first is going to be U, and after that I have to give the starting address of my program. So I have given in 1000. So first element I am putting it in first array 2000, second array 2010. After that CX is 05, AL moving with the address. So this is the address which I have to calculate, keep it ready 100C. Addition of that elements, and after that moving the value of AL to SI, and after that increment SI, after that increment DI, and after that I have to give the memory location 100C there. So halt. So I can able to press my reset. And after that one I have to give the elements of that array. So SB starting location of first array, which is going to be 2000, and I can able to give the values one by one. So at 2000 01, at 2001 it is going to be 02, at 2002 it is going to be 03, at 2003 it is going to be 04, at 2004 it is going to be 05. After that, next array is going to start from 2010. I can able to move to that memory location directly by scrolling there. 2010, I can able to give the next array 01, next array is 02, next element is 03, next element is 04, next element is 05. And after that, I have to execute my command now. So I can able to give go, reset, go, starting address of my program, space 1000, enter, executing, reset. After that one I can able to check the values in my memory location of first array 2000. So 02, 1 plus 1 2, 2 plus 2 4, 3 plus 3 6, 4 plus 4 8, 5 plus 5 0 8. So this is how I can able to write a program to add two elements or add all the elements of that array and keep it in the new memory location or in the same array of first array location. So here I have written a program for changing the first array into your final array. So if you want to take it to new memory location also, you can able to make it. So like this, I can able to do my program for adding the elements of array of two arrays and putting it in a memory location. Thank you for your patient listening.